Okay, so consider the multiplication of this instruction. How we can use this multiplication in order to perform the multiplication of these operands. Okay, so here the UMUL, unsigned multiplication long. That means, so this instruction, it is used to perform the multiplication of two 32-bit numbers, so which are there in the R2 and R3 register, and the product is 64-bit product. Okay, so this 60, in order to store the 64-bit product, so two destination registers are used. These two are the two destination registers in order to hold the 64-bit product. Okay, so R0 register, this is the destination low and this is the destination high. So R0 register holds the lower 32 bits of the 64-bit product after multiplication, and the R1 holds the higher order 32 bits of the 64-bit product. Okay, so see, consider the instruction unsigned multiplication long. So destination low, destination high, the first operand 32-bit number, second operand 32-bit number. Okay, so this operation takes place R2 into R3, 32-bit number into 32-bit number. The result is the 64-bit product. So after multiplication, we get the answer like this. Okay, so we have performed this multiplication of two 32-bit numbers. So using the scientific calculator, see here. Uh, so, um, so we have here the calculator is showing the answer for multiplication of these two 32-bit numbers. So this is the answer. See the answer. So first least significant. These are the least significant 32 bits. That is E0004 are stored in the destination loop. This is the destination loop. And here we have 1, that is the most significant 32 bits, that is inside the calci from bit number 32 to bit number 63. Most significant 32 bits are stored inside the destination high, that is the R1 register. Okay, see here we have shown the 64-bit product. So the most significant 32 bits and the least significant 32 bits. Okay, so this is how we perform the unsigned multiplication. Unsigned stands for the multiplication sign of the operands is not considered. Okay, so this is the unsigned multiplication. Okay, so now consider. So now consider the branch instruction. So why the branch instructions are required? So branch instructions, here we are discussing the branch instructions which are unconditional branch instructions. So in order to jump from one program location to the other program location, branch instructions are used. See, the four types of unconditional branch instructions are there. So see the syntax first. So see the syntax. First type of branch instruction is B. B stands for branch without any condition. So we can write the condition also if it is required. So that is why inside the curly brace we have the condition. Condition is optional. Then only one operand appears for the branch instruction, that is label. Okay, so that is the syntax of this instruction. Similarly, the syntax of branch with link, BL stands for branch with link. So only one operand, that is the user defined label. Okay, similarly branch BX stands for branch with exchange, and here we have to provide one register as the operand. Okay, and see the next type of instruction, BLX, branch exchange with link. Branch exchange with a link. So here two operands, label or RM. Okay, so that is the general purpose register. Okay, see the how this branch instruction takes place when we execute these branch instructions. So first one is the branch, and here what happens? So see the syntax of the branch instruction. We provide the label as the operand. Okay, so the address of the label is loaded into PC once we execute the branch instruction. Okay, now consider the branch with link. Here the label address, user defined label address is loaded into PC. At the same time, the address of the next instruction that appears just immediately below the branch BL instruction, that is loaded into link register. LR is the link register. Okay, now branch exchange. So here PC is loaded with the new address, and that address is obtained by performing this operation. See here, branch with exchange. It takes one general purpose register as the operand. The content of the general purpose register is logical ANDed with this number. Okay, so this operation, it gives the new address. That new address is loaded into the PC. Okay, so from this new address, the processor starts executing the program. At the same time, here the thumb bit which is there in the CPSR register is modified according to this operation. That is, the general purpose register that appears in the instruction, the least significant bit of the general purpose register is logical ANDed with the 1. Okay, so when we execute the branch with exchange instruction, the PC is modified with the new address. New address is obtained by this operation, and thumb bit in the CPSR register is modified, which is obtained by performing this operation. Okay, similarly here the branch exchange with link. So if the instruction is this instruction, so then PC is loaded with the address of the label, and the thumb bit is loaded with the 1, and the PC is once again modified with this address, and thumb bit is modified with this address, and the link register is loaded with the new address, that is the address of the next instruction that appears after the BLX instruction. Okay, so this is the branch instruction. So for branch instruction, I have not taken example. See here. So branch instruction, so which is given in the, this example is given in the textbook itself. So here we have used only the branch instruction, branch, and this is the label. Okay, so branch instruction is executed. As soon as the branch instruction is executed, the control of the program PC is loaded with the address of the label, so the control of the program jumps to the label called forward. Okay, so this is called forward jump. Okay, and see the backward jump. So the processor execute this instruction, second instruction, next instruction, then branch instruction is executed by the processor, then the PC is loaded with the label backward. So once the PC is loaded with the label address backward, the processor will go back to the label called backward. Once again the processor will begin the execution from this instruction. Okay, so this is the branch instruction. So now consider here. So one more branch with link instruction that I have considered. So here the branch with link. So what happens? PC is loaded with the new address. That address is the address of the label. At the same time, the link register is loaded with the address of the next instruction that appears immediately below the branch instruction. The address of this instruction will be loaded into the link register. Okay, so here so once the branch instruction is executed by the processor is directly jumped to the label called branch routine, subroutine. So the execution of this instruction takes place. That is the subroutine uh, body of the subroutine will be executed. Okay. So now see this one instruction. After completing the subroutine body execution, the content of the link register is loaded back to the PC. That means the link register holds the address of this instruction. So after completing the execution of the subroutine, the processor will go back to the execution of this instruction. That means the execution of the main program resumes after completing the execution of this instruction. Link register address is loaded into the PC. Okay, so this is the branch instruction. Now consider load and store instructions. So next type of instructions, load and store instructions. So we know that the load instruction which is used to load the data from the memory location to the processor register, and store instruction, it is used to move the data, to store the data from processor register to the memory locations. So that is the difference between load and store instructions. So first consider the single register transfer. In order to transfer the data between the processor register and the memory location. Okay, so here, so we have the first consider the syntax for load instruction and load and store instruction.